Hey everybody, Dr. Dan here, and this is Module 5, and in Module 5 we're covering Chapter 4 of the online text. So there's a couple of things here, and I'm presenting these topics, and I know sometimes they seem a little disjointed because in a history class typically you might want to hear things in order, like, in 1619 this happened, and then in 1700 this happened, and I'm kind of going off that script to present a number of different concepts and ideas that are important if we're to understand how business and technology affects our culture and our society. So we're sort of jumping around, but not really. So let me explain where I'm going with this. In our last chapter, in our last module, we discussed intellectual property, patents and trademarks, and the reason we did that was because in 1787, when the Constitution was ratified, there was a clause in there about promoting manufacturing and the useful arts, and it brought up this idea of trademarks and patents. And I think when you teach a class like this, it's important to talk about intellectual property up front, because as we move forward in the class, pardon me, as we move forward in the class and we talk about Thomas Edison and the light bulb, or we might talk about Alexander Graham Bell and the telephone, or Morse and the telegraph. If you ever read anything or wonder about patent protection for these guys, it's important that you know not only why intellectual property is there, why patent law is there, but also understand its purpose, which is to promote the useful arts. So we covered that in the last chapter. And now we're going to talk about something called the American System of Manufacturing. And the American System of Manufacturing is a name that historians have given to a certain kind of manufacturing. And I would argue, as a matter of fact, I don't have to argue because I know, it's not that the system of manufacturing I'm about to discuss was like invented in America. It was just named that by historians, basically. And that happens throughout history. So when you read the chapter, I talk about this idea that historians name eras like the Gilded Age or the Progressive Era, and people that were alive at those periods of time didn't really know what area they were in. It's something that historians named as a construct, and the American System of Manufacturing is very similar to that. It's a name that historians came up with. So the deal is the American System of Manufacturing is really referring to manufacturing items with interchangeable parts. And it's really important. And when you get to the discussion activity this week, I'm going to ask you a tough question about why the American System of Manufacturing, or at least how the American System of Manufacturing affects culture and society. And it's really a difficult question. There's no right or wrong, but maybe I'll give you some hints as I go through this little lecture. So the American System of Manufacturing, in a historical context, in the history of technology and the history of business, really refers to this idea of interchangeable parts. And there's some examples I give in the paper or in the chapter you're going to be reading. The first example, the most famous one, is firearm manufacturing. So back in the day, back in the 1700s, rifles were made one at a time. So one guy, made the barrel, made the trigger, made all of these components that goes into a rifle, and that was the completed rifle. And that's all well and good. That was really like a craftsman who knew how to make every component and put it together. The problem with that is that if a rifle broke in the field, for example, you couldn't take another rifle and take the trigger off of it and put it on the broken one, because the parts were not standardized. Everything was made differently. So the American System of Manufacturing is really referring to interchangeable parts, but there's really kind of more to it than that. So interchangeable parts is one thing, and then machine tools are another thing, and I'll try to explain those as best I can. So Eli Whitney went in front of the government and talked about, in the late 1700s, and tried to get the government to buy into his idea that he could make rifles faster and cheaper because he was going to make them with interchangeable parts. And his deal was that he had 3 rifles there, and he took one apart and then took the parts from the other rifle and put them in the one he took apart, just to show the government that if anything happened in the field, you could use parts from one to fix the other. It just makes sense. And it also makes sense from a manufacturing standpoint. And Whitney got this contract, and moved forward, but he couldn't keep up with his obligation of manufacturing the rifles. And the reason was, even though he was dealing with an interchangeable components or interchangeable parts concept, the parts themselves were not precisely made. So even though theoretically one trigger should fit the other, the triggers were all a little bit different as far as their tolerance were concerned, and sometimes things didn't work out as planned. Along comes machine tools, and when I talk about machine tools, I'm talking about like lathes and drill presses and milling machines that can manufacture parts in a very precise manner. So in order to have a true interchangeable part manufacturing process, the parts themselves have to be very precisely made, and machine tools are the tools, the equipment that allows manufacturers to make parts that are made to a tight tolerance. So that's sort of an important thing to know, that interchangeable parts is one thing, but the precision of the interchangeable parts is another thing. And another example, and I think I give it in my writing, is your iPhone screen. I mean, every iPhone screen is exactly the same. The tolerances are really tight. So if you break your screen, you can go to the Verizon store, to Apple, and they can replace that screen for you, because they know all of these are exactly the same. So again, probably boring you with this stuff, but it's important because I think the reason it's most significant, and here's a little hint for you if you do the discussion, I think the reason it's most significant is because it starts this process of de-skilling. In other words, back in the day, if I was the guy who was making one rifle at a time, I would be truly a craftsman. I would know, how to work the metal and how to cut the metal and how everything should fit together and should work. With the advent of machine tools used to manufacture these parts, you didn't need as much skilled labor, because you could just put a piece of metal or iron into a machine. It would shape it however it's supposed to, and every piece would be identical. It's kind of like 3D printing today. Some of you might be familiar with that. It's driven by a computer, and everything it produces is the same, because it doesn't rely on any human interaction. So that's a good thing for manufacturers, but it's probably significant as far as how American system of manufacturing affects society, is because we've lost craftsmen, and everything is standardized and everything's the same, and that's not always good. Just think of like a loaf of bread. I mean, you can go buy a loaf of Wonder Bread at the store, and every loaf is exactly the same because they're machine made. Whereas you go to a real bakery where there are actual bakers, and the breads have different variations to them. They're not all identical. So I think that's a significant effect on society, that interchangeable parts, the American system of manufacturing, has sort of taken away this need for craftsmen, and everything is always the same now. So that can be a good or a bad thing, depending upon how you look at it. But that's one effect it had on society. So you should know what the American system of manufacturing is, and of course it's important because it's sort of the precursor to this idea that in the late 1800s there's going to be an industrial revolution in the U.S., and in the late 1800s the U.S. is going to start to manufacture and produce more stuff than Europe. So there's this idea that the U.S. was kind of a laggard, but as the country grew, we became this super economy, this super manufacturer. And one of the reasons that happened was because of interchangeable parts. The other thing to understand is, you probably all know that Henry Ford was the first one in the automobile business to adopt an assembly line type technique for building cars. Well, when you think about assembly lines, and almost everything's built with an assembly line now, you have to have interchangeable, precise parts to operate an assembly line. A car goes by, you put a transmission in it, it fits exactly the same as the transmission to the next car that goes by on the assembly line. So interchangeable parts are important to be a precursor to assembly line type manufacturing. And all of these manufacturing techniques that streamline the manufacturing process start to bring prices down of goods, and also serve this this country of the United States that's rapidly growing in the 1800s and the 1900s, and all of a sudden there's a huge demand for things. There's a big demand for rifles. There's a big demand for automobiles in the early 1900s. There's a demand for watches and clocks and radios, and you can't satisfy that demand unless you have a real efficient manufacturing process, and the way to get that is to have interchangeable parts and assembly lines. So there's that part. The other thing you should take away from this is really this idea of de-skilling, and I think that's important. Again, this notion that it's not important that we have individual talents anymore because machines do stuff for us, and that's either a good thing or a bad thing depending upon your perspective. Certainly we want all of our iPhones to be the same so our screens can get fixed easily, but at the same time, often, with our automobiles or our clothing, maybe we want something really different. We don't want something that everyone else is driving or everyone else is wearing. So there's that debate on how you feel about craftsmanship versus mass production. Finally, the other thing I'll mention is a guy named Frederick Taylor, and probably should know who he is. He doesn't enter our story until late in the 1800s, but he was like the first efficiency expert ever. And Taylor is looked upon by many workers as not a positive figure because he went into factories and started to study the manufacturing process and found ways where management could get more production out of workers by making things more efficient. So maybe the worker wouldn't have to reach so far for a part to assemble, or maybe the workers, if they took shorter breaks or different kinds of breaks, they could produce more. So Taylorism is sort of his technique for making ththings efficient. Really started to steal more of the rights or freedoms away from workers because now it was dictated that, hey, you stay on this job for 3 hours, you assemble this many parts, and you don't leave until your specified break time. So Frederick Taylor, the first efficiency expert, is someone else that you should know about. So I think that's it for this chapter. If you have any questions, let me know. And next week we're going to talk about transportation technologies because, again, we're kind of going through this intellectual property in the late 1700s, the birth of modern manufacturing in the early 1800s, and then our next problem is, as the country's growing, how do we get farm goods and threshers and farm equipment and rifles, and how do we transport that stuff? Because we're talking about a period of time in the 1800s where there's no trains yet. Well, there's 1 or 2 trains probably before 1840, but no railroad, certainly no trucks or cars, no highways, no interstates, no roads, and no electricity. So how do you transport stuff? And around the time of the Constitution and the early 1800s, it was, you either transported stuff over land by horses and a cart on roads that were, non-existent, or were mud trails at best, or you started to transport things through the canal systems. And so we're going to talk about overland transportation, canal transportation, and then what takes over for canals is railroads, and then of course what takes over for railroads eventually is the highway and the internal combustion engines. So that's where we're going next week. I hope all of this is making sense to you. Thanks a lot, and I'll talk to you again soon. Thanks. Bye-bye.